So Boyle's law states that the volume of a fixed mass of gas is inversely proportional to its pressure, provided that the temperature remains constant. So the mathematical interpretation of this is as follows. Phi is inversely proportional to P, then Phi is equals to K over P, then K is equals to Vp when you cross multiply. Then you have Phi1 P1 equals Phi2 P2. So that's the first equation in this lesson that you have to note. So maybe you should just jot it down somewhere. The next one is the Charles law. And Charles law states that the volume of a fixed mass of gas is directly proportional to its temperature, provided that the pressure remains constant. And the mathematical interpretation of this is phi is directly proportional to T. Then phi is equals to KT. Then K is equals to phi over T. Then we have phi1 over T1 is equals to phi2 over T2. That one aside as well. So just note the second equation as well. So the third equation here is the Dalton's law of partial pressure, which states that if there is a mixture of gases that do not react chemically together, then the total pressure exerted by the mixture is the sum of the partial pressures of the individual gases that make up the mixture. And this law is very easy to understand. It's just as saying you're having two gases A and B, gas A and B, that form a particular mixture. The total pressure of that mixture is the sum of the pressure of the first gas, gas A, and the second gas, gas B. So, and the implication of this is that if a gas is collected over water, maybe during the preparation of that gas, so the total pressure of that gas won't be the pressure of the dry gas. It will be the pressure of the gas plus the pressure of the water vapor. Then, to get the pressure of that gas, of that dry gas now, you have to what? You have to subtract the pressure of the water vapor at that particular temperature and pressure from the total pressure. So, and that's the equation that you need here. So the next thing we need to know is the general gas equation, which is just the combination of Boyle's law and Charles' law. So, and the equation is just P1 Phi1 over T1 is equal to P2 Phi2 over T2. So this is the fourth equation I will be giving you in this lesson. Just note that one too as well. So the next law is the Graham's law of diffusion, which states that the rate of diffusion of a gas is inversely proportional to its square root of its density, to the square root of its density, provided that the temperature and pressure remain constant. So here now, I won't be using the density, I will be using the relative molecular mass, because the density is actually directly proportional to the relative molecular mass of a gas. So R is inversely proportional to the square root of relative molecular mass. R is equals to K over square root of relative molecular mass, then K is equals to R square root of relative molecular mass. So from here, if you rearrange, you get R1 over R2 is equal to square root of relative molecular mass of the second gas divided by the relative molecular mass, square root of relative molecular mass of the first gas. So that's the fifth equation here now. So just try and note that one as well. So before we start solving the past question, note it very well, because I'm going to remove it from the screen right now and display the questions. So the first question here is 1989 question 6. So, and what is the partial pressure of hydrogen gas collected over water at standard atmospheric pressure? So it is collected over water, which means the total pressure will be the pressure of hydrogen gas plus pressure of the water vapor. Now, at what pressure was it collected? It was collected at 760 millimeter of mercury, because it's what? It is at standard atmospheric pressure, which is 760 millimeter of mercury. So the total pressure is 760 millimeter of mercury, which is the sum of the pressure of dry hydrogen gas and that of water vapor. So now, if the saturated vapor pressure of water is 23 millimeter of mercury at that temperature, what is the partial pressure of hydrogen gas? So it's very simple. You just subtract the saturated vapor pressure of water vapor from that of the total pressure, which is 760 millimeter mercury, and you get your pressure for dry hydrogen gas. So now the next question is question 5 of year 2000. Yeah, 2000. So the partial pressure of oxygen in the sample of air is 452 millimeter of mercury and the total pressure is 780 millimeter of mercury. What is the mole fraction of oxygen? So this question as well, but I forgot to mention the formula during the previous lesson. The partial pressure is equal to mole fraction of that constituent multiplied by the total pressure, which means 452 is equal to the mole fraction multiplied by the total pressure, which is 780 millimeter of mercury. So from there you get your mole fraction to be 452 divided by 780. So 452 divided by 780, which gives 0.579. That is option B. So the next question is question 5 of 2013. So which says the rate of diffusion of gas Y is twice that of Z if the relative molecular mass of Y is 64 and the two gases diffuse under the same condition. What is the relative molecular mass of Z? The rate of diffusion of Y will be Ry. Now, that of Z will be Rz. Now, since the rate of diffusion of Y is twice that of Rz, then we say Ry is 2 times Rz. Now, when we set up the equation, we have Ry over Rz equal square root of relative molecular mass of Z divided by the square root of relative molecular mass of Y. Now, since R of Y is equals to 2R of Z, so we have 2R of Z divided by R of Z is equals to relative molecular mass of Z over square root of 64 because the relative molecular mass of Y is 64. So from here we have Rz cancel out Z, so we have 2 is equals to square root of relative molecular mass of Z divided by the square root of 64. And when you do the calculation very well, you get the relative molecular mass of Z to be 256. So which means there is no correct option in this question now. So the next question is question 4 of 1995. So what volume of oxygen will remain after reacting 8 cm cube of hydrogen with 20 cm cube of oxygen? So according to Gay-Lussac law of combining volume, so when gases want to react, they do so, they react in volume, which bear a simple ratio to one another and to that of product if the product is also a gas. So now when oxygen reacts with hydrogen, they will react according to the equation you see on the screen. So which is 2H2 plus O2 to give 2H2. So the implication of this is that if we have two volume of hydrogen that is reacting, one volume of oxygen will be reacting with it. I will be having two volume of H2O that will be formed. So let's say now we're having 10 cm cube of hydrogen. So definitely we'll be having 5 cm cube of oxygen that will be reacting with it. That is in 2 ratio 1, 10 ratio 5 is 2 ratio 1. Then 10 cm cube of H2O will also be formed because it is 2 ratio 1 ratio 2. So which means now if you check the equation, they said 8 cm cube of hydrogen is reacting. So definitely half of it will be reacting with it. So we're having 4 cm cube of oxygen that will be reacting with what? That will be reacting with 8 cm cube of hydrogen. So which means the remaining volume of oxygen will be 16 cm cube because the total volume is 20 cm cube. So only 4 is reacting out of it. So which means we'll be having 16 cm cube left. So the next question is question 3 of 1986. So which says 10 cm cube of hydrogen fluoride gas react with 5 cm cube of dinitrogen difluoride gas to form 10 cm cube of a single gas. So which of the following is the most likely equation of the reaction? So what you have to do is just to write out the total volume that react. So 10 cm cube of hydrogen fluoride react with 5 cm cube of dinitrogen difluoride to form 10 cm cube of another single gas. So just find out the ratio. So all of these have 5 as a common factor. So which means 5 in 10 will give us 2 and 5 in 5 will give us 1 and 5 in 10 will also give us 2. So which means all these gases they react in 2 ratio 1 ratio 2. So which means HF should have 2 as its coefficient and N2 F2 should have 1 as its coefficient and NHF should have 2 as its coefficient. So the only correct option here is option B. So option B is the correct answer. So they will react in 2 ratio 1 ratio 2. So the next question now is question 30 of 1981. 28.8 cm cube of nitrogen at 15 degrees Celsius is cooled at 0 degrees Celsius at constant pressure. So the new volume is they're asking us the new volume. Now, the key point here is that it's at constant pressure. So, and the law that is going to guide us in this question is the Charles law because it is at constant pressure. So now, we know that phi1 over T1 is equals to phi2 over T2 for Charles law. So what is phi1? Phi1 is the 28.8 cm cube that was firstly given. Then the T1 is the 15 degrees Celsius, so which we are going to convert into Kelvin by adding 273 to it, so which will give us 288 Kelvin. Then Phi2 is what we are looking for, and and T2 is the 0 degrees Celsius, which is that amount to 273 Kelvin. So if you set up the equation Phi1 over T1 is equal to Phi2 over T2, you have 28.8 cm cube divided by 288, which is equal to Phi2 over 273. So when you make Phi2 the subject of the formula, you get 27.30 as your answer, 27.30 cm cube. And the next question is question 6 of 1991, which states a given quantity of gas occupies a volume of 228 cm cube at a pressure of 750 millimeter mercury. What will be its volume at atmospheric pressure? So obviously we can see it's just a relationship between pressure and volume, so which is given by Boyle's law. And one more important thing is that from the question, they didn't tell us that it is at constant temperature, but it is not necessary. Once we can see that it is just the relationship between volume and pressure, that is, as volume is changing, it is affecting the pressure as well. So we definitely know that it is Boyle's law that we are going to use. So Phi1 is equals to 228 cm cube, P1 is 750 millimeter of mercury, P2, which is the unknown, and the P2 is the atmospheric pressure, which is on 760 millimeter of mercury. So from Boyle's law, Phi1 P1 is equals to Phi2 P2. So we have 228 cm cube multiplied by 750 millimeter of mercury to give Phi2 multiplied by 760 millimeter of mercury. So if you make Phi2 the subject of the formula, you have 228 cm cube multiplied by 750 millimeter of mercury divided by 760 millimeter of mercury, which when you press it in your calculator, you have 228 multiplied by 750 divided by 760 millimeter of mercury. So this gives 225 cm cubed, which is option B. The next question is question 5 of 1994. To what temperature must a gas 273 Kelvin be heated in order to double both its volume and pressure? This question is quite easy. It's a relationship between temperature, pressure, and volume, which is given by the general gas equation. So now the first value given here is the T1, that is the initial temperature to be 273 Kelvin. So now to what temperature must, so they're asking us of T2, that is what temperature will we now increase it to? Okay, so now to double both its volume and pressure. So we are looking for T2. We already know T1. Now, what about the volume and pressure? So since it's not specific, we definitely know that we have a particular volume initially. So let's say that one is phi. Let's say phi1 is equals to phi, a particular volume. Now, and P1 also, let's say it is P, a particular pressure. Now, phi2 will now be what? That is 2 times the initial volume, which is 2 phi. Then P2 will also be what? 2 times the initial pressure, which is 2P. So now we use the general gas equation, which is P1 Phi1 over T1 is equal to P2 Phi2 over T2. Then we input it. So P1 is P times Phi1, which is Phi, divided by T1, which is 273 Kelvin, equal P2, which is 2P, then times Phi2, which is 2 Phi, over T2 that we have to find. Now when you cross multiply, you have T2P phi is equal to 273 multiplied by 2 multiplied by 2 multiplied by P phi. Then if you divide both sides by P phi, you have T2 is equal to 273 multiplied by 2 times 2, which is 273 multiplied by 4. So then T2 is now equal to 273 multiplied by 4, which gives 1092 Kelvin. So, and that's our final temperature. So, which means option D is right for this question. And the next question is question 6 of 1995. So, two cylinders A and B each contains 30 cm cube of oxygen and nitrogen respectively at the same temperature and pressure. If there are 5 moles of nitrogen, then the mass of oxygen is. Now, they're asking us for the mass of oxygen in that second cylinder, and it's quite easy to know. The two cylinders are of the same volume, which is 30 cm cube. They have the same volume, and which means the volume of oxygen in the first cylinder is equal to the volume of nitrogen in the second cylinder. So now Avogadro's law states that equal volume of all the gases at the same temperature and pressure contains the same number of molecules. So which means oxygen and nitrogen, they have the same volume and they are at the same temperature and pressure. So which means they must have the same number of molecule. That is the same number of mole. So having knowing that, we are only given 5 mole of nitrogen. So by implication, it means oxygen also have 5 mole of it present in that second cylinder. So now to know the mass of oxygen now, the number of mole is equals to mass over molar mass. Okay, so now from there, if you cross multiply, you get mass is equals to number of mole multiplied by molar mass. So the number of mole of oxygen now is 5 moles, while that of the molar mass of oxygen is 32 grams per mole. So when you multiply it, you get mass is equal to 32 grams per mole multiplied by 5 moles. So from there you get 32 multiplied by 5 to give 160. So the mass of oxygen in that cylinder is 160 grams. So which is the option D. And the next question is question 4 of 2012. So which is 50 cm cube of a gas was collected over water. So the 50 cm cube will be our P1 like that at 10 degrees Celsius. So that is our T1. So T1 is equals to 10 degrees Celsius, then plus 273 to give us 283 Kelvin and 765 millimeter of mercury. So we already know that this won't be the pressure of the gas. It will be the pressure of the gas plus that of water, because it was collected over water. So now to get the pressure of the gas, we have to subtract the pressure of water vapor at that temperature from the total pressure, which is 765 millimeter of mercury. So to get the pressure of the gas now, it will be 765 millimeter of mercury minus 5 millimeter of mercury. That is the saturated vapor pressure at that temperature. Then which will give us 760 millimeter of mercury, which is our P1. Then calculate the volume of the gas at STP. So we should calculate the volume, which means the V2 at STP, that is standard temperature and pressure. So ST, which is the standard temperature, will be our T2, which is 273 Kelvin, and SP, which is the standard pressure, will be our P2, which is the 760 millimeter of mercury. Now if you check this thing very well, you see that the P doesn't change. That is P1 is equal to P2. It doesn't change at all. So it still remains the same at 760 millimeter of mercury. So intuitively, this is Charles law because it has constant pressure. But if you still want to use the general gas equation, you can still proceed and say P1 V1 over T1 is equal to P2 V2 over T2. So since P1 and P2 are the same, you can just cancel them out and you still have your V1 over T1 is equal to V2 over T2 as well. So from there you get, or you can still decide to use the general gas equation and get P1 V1 over T1 is equals to P2 V2 over T2, which will give you 260 times 50 divided by 283, which is equals to 760 times V2 divided by 273. Then when you make the V2 the subject of the formula, you get 760 multiplied by 50 multiplied by 273 divided by 70 multiplied by 283. So when you press this in your calculator, you get 760 multiplied by 50 multiplied by 273 divided by 760 times 283. That one will be in bracket. Then you get 48.23 as your answer. And the next question is question 5 of 2004. So according to Charles' law, the volume of a gas becomes zero at, okay, so they are asking us the temperature at which the volume of a gas becomes zero. So basically, you can get this at your textbooks, like the graphical representation of Charles' law. But due to the nature of this tutorial, I want to be able to display the graphical representation of Charles' law. Another alternative way to get the answer is by using calculation. So let's say the volume of that gas initially was V1 is equals to V, a particular volume that we don't know. Let's say it's V when it was not zero, and it will have a particular temperature as well, T1 equal T. Then now let's say the volume now changes to 0. So what will now be, let's say the phi2 is now equal to 0. It changed from phi to 0. So what will now be the T2? Because that was what they're asking. That is, what will be the temperature when the volume is 0? So now let's start. So we can set up the equation and say phi1 over T1 equal to phi2 over T2. So since phi1 is phi over T1 is T, equal phi2 is 0 and T2 is equals to the temperature we are looking for that we want to find. So from here now, if you cross multiply, you have phi T2 is equals to T times 0. Then you have phi T2 equals 0. Then if you divide both sides by phi, we get T2 to be equal to 0 over phi, which is equal to 0 Kelvin. And when you are using Charles law, it means your temperature is in Kelvin. So another problem is that we got our T2 to be 0 Kelvin. But from the options, all our answers are in degree Celsius. So which means we have to convert this 0 Kelvin to uh, degree Celsius. So I know that temperature in Kelvin is equal to temperature in Celsius plus 273. So temperature is Kelvin is 0 Kelvin is equals to temperature in Celsius plus 273. So temperature in Celsius is equal to 0 minus 273. So we have 0, that's minus 273 degrees Celsius. And that's option C. Thanks for taking your time to watch this tutorial. I do really appreciate you and I wish you best of luck in your upcoming Jamb examination. So if you enjoyed this video, give it a thumbs up. Don't forget to give it a thumbs up and subscribe to this channel for more lessons like this, for more question and answer sessions like this. I'll make sure I upload some videos under Jamb topics like this. So maybe in form of a lesson or question and answer like this before your Jamb examination. And if you are going to be offering some courses, some chemistry courses in your undergraduate studies, so make sure you subscribe to this channel so that you won't miss any of my videos that will be uploaded very soon. This on considering the undergraduate studies before you even gain your admission and after you gain your admission. And more videos are coming up on Olympiad chemistry, YA chemistry, Cambridge chemistry, and some other exam body like that. So just don't forget to subscribe to this channel and press the notification bell so that you'll be notified whenever I release any video. So see you in the next video. Bye.